Welcome to today's webinar. Thank you for joining us. My name is Ina Agastra, Senior Manager of Academic Programs here at AMPL Optimization, and I'm your moderator for today. I'm joined by my colleagues Juan Bojorquez and Eduardo Salazar, Technical Account Managers at AMPL, who will be leading our session on the evolution of the modern AMPL stack for teaching optimization. Today's session is being recorded. The live Q&A is also available, so please feel free to send your questions there, and we'll be happy to answer them at the end of the session, or you can also email us at academia@ampl.com, and we'll be happy to follow up. And with that, I'm going to turn it over to Eduardo and Juan.
Thank you, Ina, for the introduction. Yeah, as she has just said, today we'll be covering the part one of our training modern AMPL for professors specifically. I'm sure that many here already use AMPL in their courses. The idea of these webinars across today and Thursday is to show you how to move your course to modern AMPL. AMPL itself hasn't changed a lot. The syntax is the same. The model files are still model files, but the ecosystem around it has evolved. So the purpose of these webinars is to show you specifically what does this new ecosystem looks like and how can you work and move towards this data ecosystem for all of your classes. So I'll be joined by my colleague Juan, and I guess we'll take it from here then. I'll share my screen and you guys let me know if you can see my presentation, please.
Yeah, it's great to be here with Eduardo presenting this. Just for everyone to know, we'll probably go a little bit deeper into this in a few seconds, but today we're going to talk about how the modern AMPL stack actually looks like. And the second part will be leading a hands-on part. So yeah, but Eduardo is going to tell you about it a little bit more.
Yeah, as Juan has just said, the purpose of today's webinar is to introduce what's actually changed and the idea of moving towards that. And on Thursday, we'll have a more hands-on approach. We'll go over code and activating licenses and so on. Today, we'll go over today just a little bit, just to tease you. But Thursday will be the hands-on session. So without further ado, let's get started. Today's agenda, what we're going to talk about specifically today. We're going to talk about why the stack moved, what has changed, and why has it changed. Then we're going to move on to the AMPL Python API, better known as AMPL Py. And then through the use of AMPL Py, we'll show how can you connect your data and your solvers through a Python layer. We'll do a quick rundown of our current toolkit and a live demo on how it actually looks like. And then to close it up, we'll talk about our new academic licensing options. And for the part two, which is next session, we'll be having a hands-on approach. So be ready for that. So I would like to actually make a poll in the Zoom chat, just for us to have a general idea of where you're currently located when teaching AMPL and using AMPL for your courses. So it'll be showing up on your screens as a little pop-up poll. It should be showing up any second now, just for us to get an idea of how are we doing so far, right? So the first part is using only the legacy IDE. Part the answer B is exploring Python tooling. C is already teaching with notebooks, or D is mixed across courses. So as we're aware, many of you may have not just a single course that uses AMPL, but many of them. So it depends from course to course. So answers are coming in. Thank you very much. The majority so far has been the A option, legacy IDE only, which is more or less what we expected. So I'll keep it briefly just for a few more seconds. But yeah, I think we can safely say that 69% of you answered with using only the NC, exploring Python tooling, and already teaching with notebooks. So this is expected. The legacy ID is what everyone with teaching and learning Apple was brought up with. So we don't mean to say that the legacy ID is bad, but nowadays we have better options which should be made evident across the webinar. So I'll be ending the poll now. Thank you very much for participating. Sharing the results is for you to see. So yeah, moving on then. What has changed and why has it changed, right? Ample itself hasn't changed. The syntax is the same. You are all familiar with it. The syntax of representing your variables, your parameters, your sets, the objective functions, the constraints, all of that has stayed untouched. The same Ample model you ran in the 90s should be able to run today, provided the solver is still around. But the point is that Ample hasn't changed, but the world around it has. As you may be aware, and nowadays Python shows up basically everywhere, not only in academia itself, but okay, we have a question already. I'll answer it right away. The question is, I'm using Vim with Ample compiler. Is it like IDE legacy? Um, yeah, yeah, we could say that it's more or less like the IDE legacy workflow. What we are going to show today is a different workflow that ideally should be adopted because of the advantages that we will present. Continuing with the presentation, as you know, Python shows up everywhere now, from data science courses to machine learning to even general engineering and computational coursework across different fields, computational biology, geostatistics, and so on. So the idea of it is how can we enable Ample to also run and connect with Python and the whole ecosystem of libraries. As you know, Python is the most used language, so it also has quite a large number of libraries to connect with any data source, with different models and so on. The other stuff that has changed around Ample is the presence of Jupyter notebooks. For those that are not aware, Jupyter notebooks basically enable you to have a different form factor for running code. As the name implies, as a notebook, you run cell by cell pieces of code or pieces of text. So a notebook will be a self-documenting form factor for code that you can share and run not only in your computer, but also using the cloud. Which brings us to our last point, cloud first students. As you know, the world is quite different from what it looked like a couple of years ago. Nowadays, users or students use Chromebooks, for example, or they use restricted computing equipment in which they have no admin rights for installing and downloading stuff on their own. And the expectation is that now you can just paste a link and it should work in any browser tab, right? So we want to move towards that direction as well. Going back to the point that Ample hasn't changed, but the world around it has. So we need to stay on top and modernize and have better workflows around it. As I told you, the mod files still work. The syntax is the same. The models should not break at any point. We are constantly improving Ample and introducing new features and performance improvements, but at no point are we going to introduce breaking changes. Your legacy models, if you run through the classical IDE, the production.mod file, and your .dat files and your run files, they continue to work. But we want to show you a better way, a more modern way of running and doing Ample work. On the left, we have your classic production.mod file. We have a variable, we have an objective function and a constraint. And on the right, we have an example of what a Jupyter notebook cell looks like. So for example, instead of having a file specifically, you can just define your models on the fly using this ample magic command, this ample eval instruction will allow the ample interpreter to evaluate this expression. And not only this model, but you can add more expressions, constraints, variables on the fly across your notebook, and it should continue to work. The ample language is identical. As you can see, nothing has changed specific to the language, but everything wrapping it, the Python orchestrator, the notebooks, package management, the cloud licensing, that has changed. So the purpose of this is to show you how to move towards that direction. What we are providing is a better toolbox. For the editor's part, I'm sure you're all familiar with the classical IDE, with the legacy IDE, in which you can work with your model files, your DAT files, your ROM files, and you run your AMPL code through the IDE. We are not removing the IDE from AMPL installations. We are planning to transition away from it. We are deprecating it. It's still useful, of course, you can still use it, but we would like for you to move on to a better platform. This better platform is called Visual Studio Code. Visual Studio Code is a text editor by Microsoft. It's the most used text editor in the world. It's quite popular, and the strength of Visual Studio Code is that it's able to take in many extensions. So, for example, if you are programming with Python, you download Visual Studio Code and you download your Python extensions. If you're working with, say, C++, C Sharp, Java, you can plug in your C++, C Sharp, Java extensions. If you're working with data frames with CSV files, you can download the specific CSV extensions. And that's exactly what we're doing with AMPL. We are providing an official AMPL extension for Visual Studio Code, which will enable you to have syntax highlighting and connecting with AMPL and running your AMPL code directly from Visual Studio Code. As a reminder, Visual Studio Code is an open source and completely free platform, so you are not paying anyone for anything of this. Moving on to our second point is AMPL which is the AMPL Python API. AMPL doesn't change, but the way you call it and the way you retrieve results and set data, you can do this programmatically through Python, enabling you to access the whole Python ecosystem. And lastly, the Jupyter Notebooks, which we have already talked about. This is a new form factor, relatively new, I could say, of how to run code, and specifically code in the sense of academic and educational contexts. On the cloud platform, we are introducing you to Google Colab. For those of you that are not aware, it's a platform by Google that allows you to run Jupyter Notebooks and code on the cloud without installing anything on your computer. It runs on Google's servers and infrastructure, and it's as simple as sharing a link. You can think of this as Google Drive for code. You share a link with your students, with your users, and they should be able to run and copy and edit the same notebook on their own. We also have the MO book, the mathematical optimization book. Many of you may have learned AMPL through the Panther, the classic AMPL Panther book, the one with the Black Panther on the cover. MO book is not a new version of that book. It's actually a completely new book on its own. It's a book made by several professors across the world to teach mathematical optimization using a modern workflow of AMPL and Python. And the advantage of the MO book is that every single chapter can run as a Google Colab notebook. So you can pick, for example, if you want to teach about convex optimization, you can go to the convex chapter of the MO book and start picking some of their notebooks for them. If you want to teach about a nonlinear optimization, then you go to the nonlinear section and so on. And lastly, how can we distribute Python and AMPL better? I don't know how hard of a time do you face when installing AMPL, when installing solvers, when setting up in a cluster. But the idea is that using AMPL and AMPL Py will allow you to have a better time, a better experience with installing and updating and managing your AMPL installations and licenses. So through the use of a single command, you can run this same command across every platform, Mac, Windows, Linux, Colab, and it should be quite easy to install AMPL and the solvers. So what does all of this actually looks like now that I have introduced
Yeah.
this?
Sorry, Edu, I wanted to reinforce something you mentioned there. Is that the legacy tools like the IDE or the way sorry, the attendee that asked the question, I don't remember the name, asked, they're still gonna work. What we're trying to do here is to convince you that there are maybe some aids, some better ways of doing things, especially for your courses, which is the focus of this webinar. So yeah, basically the legacy tools are still working. Specifically, the legacy IDE is no longer maintained. but you can still use it. But the point here is to convince you that these tools will make your life easier. And also a note on the official extension by Ample. The official one is for VS Code. Uh, we'll see that on Thursday you'll find some other extensions by the community. Uh, but we're only providing an official extension for VS Code. If you use another text editor, you probably can find a community kind of extension. Just for you to know that we're providing an official one in VS Code. Yeah, and then I think you briefly mentioned the ample bot. We'll probably look at it later on today. So basically, this is kind of LLM kind of assistant for you. Yeah, well, I won't dive deeper right now into it, but we'll look at it later. Just those points. Thank you.
Yeah, that's a very good point. We'll talk about the ample bot later, but just for you to get a little taste of it. So moving on, what does this toolbox actually looks like now that I have spoken to you about this? What's Ample Pi really? Uh, as you may be aware, Ample has mod files that define the models. They have dot files that define the data. Your sets, your parameters, your tables, they all live there. And then lastly, you may also use .run files. The run files are the scripting language that brings everything together. Through the use of run scripts, you can read your models, read your data, change it if you have to change it, set solvers, set the option of the solver, perform the solve, and then do some programmatic scripts, right? This works. We are not taking this option away. The purpose the point we're trying to make is that at no point we are going to take tools away from you. We just want to show you a better way of doing things. As you may be aware as well, more people in the world know Python or are familiar with Python than they are familiar with ROM files from Ample. So the rationale behind using Ample Py, the Python API, is that instead of locking your scripts to the Ample run language, you can use a friendly language, which is Python, and you can connect to the ecosystem of Python across every single platform. So what does this actually looks like in a snippet of code? You read your model file. This doesn't change. It's the same production mode that we saw earlier. But for example, if you want to bring in your data, instead of loading it with that file, you can load it from many different data sources. As an example, we're using a CSV file, which is just a comma separated value file, just looks like an Excel table. And we're using the pandas library, which is a data frames and data manipulation library in Python. So we read the CSV files, and then we can just set the data of our model in Ample to read data coming in from the CSV files. And then we set our solver and we just solve using Python instructions. And that's it. Like this shouldn't be hard to follow. And on the second snippet on the right, we are going to show you how can you actually manipulate and work with an ample result now that the problem has been optimized. So with the first instruction, as the name implies, you get the value of the variable, and you can just manipulate that value using the pandas data frames, which are quite ubiquitous in data science and data engineering and machine learning. You can use plot libraries of the Python ecosystem, Matplotlib being the most popular one. You can use it to plot your variable results. And lastly, obviously, you can also interact with your objective function. Not shown here, but you can interact with your dual variables, with your reduced costs and so on, with your Slack as well. So uh, all of everything that you can do using ROM files, you can also do with Ample Py. The main advantage point for you to understand is that you are no longer locked or tied to a Ample script that is a bit archaic and that people have a harder time running or understanding. The Python code should be more transparent and easier to follow, not only for you or your colleagues, but also for your students. The model is the only thing in Apple syntax. And again, making a final revision, the AMPL syntax hasn't changed, and we're not planning to change it. The model should be quite the same, but the tooling around it has changed. Why does this matter specifically for teaching and for research? Um, you can use Git, which is the version control system that the world uses. You can have the full history of the diffs between versions, not only of your code for research, but also for student assignments. You can check in, okay, so what has changed between versions? Have you done any recent work? Have you solved the latest question using notebooks and the mod files? If you're running, for example, a complex research problem, you want to tune out your solver, you can solve hundreds of variants of your same problem using a Python loop. You can orchestrate your runs through using Python. If you want to consume a vast amount of data, instead of hand editing your DAT files, you can just bring in Python to read them programmatically. Let's say you have I don't know, a problem in which you are working with a data source coming in from NASA, just to give you an example. You can use Python to access the NASA data sources APIs, and then you can read those and feed them to your AMPL model. And AMPL won't care about where does this data come from, but Python will give you an easier time accessing the data. And lastly, these files, the IPNB files, these are the Jupyter Notebook files. So once you have a Jupyter Notebook working and running, you can share it for your users to run them on their own laptops, on a Google Colab tab, on a cloud instance of AWS or Azure or whatever, and this should work. This should solve the problem of, Professor, this runs on your machine, but actually in my machine it cannot run because of XYZ reasons. Jupyter Notebooks should be able to fix these issues. They are quite evident, another advantage of sharing. We have a question by Elias. I'll answer it right away. The IDE allow you to debug a mod or that file. Can you show an example of how to do this in the new environment? We'll share that example in the hands-on session on Thursday. It's a very good question, so we'll keep it in mind. For sure, on Thursday you will see how can we debug a mod or that file using the new workflow. So yeah, thank you for the question.
Yeah, also there, as you will see on Thursday, you you don't always will have to use that file actually. So even though you don't have that file, but you have like the processing data in Python, so you can debug your Python code like quite literally for that part. For the mod part, also errors that may arise will be printed through Python to specific the line. So yeah, that also supports a little bit of that, but we'll look at it in more detail on Thursday.
Yep. So yeah, this is the point we want to make. At no point we are forbidding you to do anything. You are free to do whatever you want, to use AMPL the way you want to use it, the way it works for you, the courses, the research. But we would like to show you and to make evident the value and the advantage of moving to the new platform, to the more modern workflow. The classical example is, for example, if you have a facility location problem, you have your set of plants that you want to open and the capacity of each plant. This works, and this has worked for decades. We are not saying that this is incorrect, but there's a better way of doing things. So when you change to AmplePy and to Python and the whole new framing and ecosystem, instead of reading a hard-coded dot file, which follows a very specific syntax, you can work with data sources that are agnostic to the end use that it's going to take. So for example, this CSV file, um, it doesn't care if it's being used for an optimization problem. It doesn't care if it's being used for a machine learning forecasting model, or if it's being used for a plotting purpose, or if it's being used for anything. It doesn't care. What we care about it is actually the data that it data, then we can later on use it to feed our AMPL models, which is what we are using in the second code snippet. It drives the same model, the same .mod file is the same, it doesn't change. Your same objective function, your variables, your constraints, that stays the same. But what we're changing is how you input your data and how you process it. The modern world is quite complex, so data sources change all of the time. For example, if you are solving an optimization problem in your classroom that depends on real world data changing from day to day, having a hard coded that file and you having you to change it every single day is quite cumbersome. So what AmplePy and the new data sources allow you to do is that you can just pull up whatever data set that you're working with, and you no longer have to worry about the data being out of date, right? So your data may live in CSV files, in databases, in APIs. It no longer has to live in DAT files. Again, it's not that we are removing that files or that they no longer will work. They will continue to work, but we want to make it evident that there are better ways of doing this, right?
Yeah, I'll complement a little bit on that. So yeah, I think Eduardo make the point, the important point there, and you can still use the dot files if you want to. Probably for toy problems that may look easier, especially in the teaching part of it. But the idea here is also to give the students the tools or equip them with tools that we are seeing that industry is using. And it's going to be hard to find industries using very nice formatted dot files. They're probably basically connecting to APIs to extracting data and solving these optimization problems. So that's part of the focus here to kind of integrate or bridge what is being used in industry with what is being taught in academy also.
Yeah, exactly. That's the point of the ample transition. We want the students to learn the tools that they will actually end up using in the real world. Like obviously, for some educational purposes, that files are right; they are the correct approach. But as you work through more complex problems and the real world needs, you will have to, or ideally, it should be evident that using Ample and AmplePy and connecting to different data sources is a better approach. How Ample actually plugs into Python? Like, okay, I have shown you snippets, what it actually looks like to install AmplePy and run Ample through Python. So for those of you that are not aware, pip, Python package manager. Through pip, you install your packages or libraries and you handle them. So now installing solvers and installing Ample as a whole is as simple as running these three commands. The first command, Python -m pip install AmplePy. What this will do is that this will install a localized version of Ample specific to Python and the Python API for Ample. So with this, you now have access to Ample through Python. The second command, AmplePy modules, install Hikes, Gurobi, Express, Simplex. This enables you to install any solver that you want. For now, we have just, this example is just installing the Hike solver, which is a MIP solver open source. And then we have the big three MIP solvers, right? Gurobi, Express, Simplex. But you can install any solver that you use. Conot, for example, for nonlinear stuff, or if you use Mosaic for conic programming, or if you use Nitro for nonlinear, you can install it using the same way. And lastly, the last command activates license. This will activate your Ample and your solver licenses. Nowadays, we are managing the licenses using UUIDs. UUID stands for Universal Identifiers. It's just a collection, a string of letters and numbers that will identify your specific license. And through these three commands, you are able to install Ample, to install the solvers, and to activate your license. So you don't have to worry about downloading an installer and going through the user interface of installing it, changing your path environment variables, If you want to, for example, download a separate solver, you no longer have to worry about a separate download specific for the module of that solver. And these three commands, they should run on every single platform. They should run on Windows, on macOS, on Linux, on Google Colab, on cloud instances, on virtual machines. These three commands are exactly the same. It doesn't change. And as you see, these are quite simple. So this is what also enables you to share these instructions with your students. Maybe some students have a hard time installing AMPL, going through the user interface of the solver or setting up solvers and so on. This should go away or mitigate most of these pain points running these three commands. We have another question. I'll take it right away. Nelson asks, are there API functions that will output a dot file from these other data sources? I can imagine cases in my research and coursework where the dot file is the better tool agnostic format, as it can be shared among the different language API AMPL now makes available. That's a very good question. And to answer it, I think that we don't have that capability. Um, it's not like we're missing it, but the point is that you make a very good point. Right now, we're focusing on AmplePy and Python, but there are other languages that Ample can connect to through the use of APIs. We support C, C++, C Sharp, Java, MATLAB, R. I guess that's it. So, for example, if you are more familiar with, say, C++ or C Sharp, you are also free to use Apple through the language extension, through the language API.
Yeah,
However,
go
yeah,
ahead, please. Sorry.
yeah. However, as Nelson has said, these dot files should also work through every single different language. So it should work through C++, through C Sharp, through Java. That doesn't change. And the point of these other data sources is that they should also work with other different language APIs. So if you're reading a CSV file from Python, you should be able to read that same CSV file and interpret the same data using, say, Java or C Sharp. That's also an advantage of these data sources, that they are also agnostic of the language that you end up consuming the data from. But to answer your question, I don't think we have that capability. We'll look into it if it's feasible for us to add. But that's exactly the advantage of Ample and the Python, and not only Python language APIs, is that you are free to use your DAT files. You can definitely use them and keep on using them. But if you want to use a different data source, you can also use it.
Yeah, I was gonna comment something on those lines. Basically, CSV files are also kind of language agnostic in the end. But even though we don't provide like a specific function to export that files, there could be a workaround, and I'll have something for it for the next section. But basically, that workaround is the snapshot feature. So basically, a snapshot feature basically captures your ample session. And in your ample session, you got the model declaration, the data declaration, and the options settings. So uh, you could have a kind of that works today as a workaround using this snapshot feature and enable only the data part. Will give a pretty similar kind of data structure that than a dot file has. So that kind of is the current way or workaround if you definitely needs to have that file exporting feature. And we'll take a few minutes towards the end of the second part on Thursday to look at it. So yeah, that's what I could provide there to do that kind of thing, exporting a similar to that file. Yeah.
Yep. Yeah. So moving on. Again, as you know, another strength point of Ample is that you can change solvers on the fly. The model and the problem is agnostic of whatever solver you're using. You want to, for example, solve a toy problem using an open source solver. You can use Hikes, for example. But if you are moving to tougher problems, to problems with, say, non-linearities, quadratic constraints, and so on, then you reach out for the correct solver for your problem. In this case, we are just showing you how, with these three simple lines, you change the solver from Higgs to Groby to simplex, and you solve the same problem. Obviously, through Python, you can also set the solver options. As you know, solvers have many different options that you can tune and change that impact the performance of the solver. For example, the direction that the branch and bound tree should take, how many threads are you assigning to your workload, and so on. All of these can be programmatically set up through Python. There's also one additional point that we like to cover, which is the AMPL MP driver. MP is basically the interface between AMPL and the solvers. And this MP driver allows us to have newer expressions added to AMPL. What already works hasn't changed, but for example, if you want to do an implication constraint, as you know, having an implication constraint typically means that you have to reach out to big M linearization. You have to introduce additional variables, auxiliary variables, linking constraints, and so on. So for teaching purposes, it's definitely important to teach your students how to model these complex constraints. However, the advantage of MP is that you can have these logical or conditional constraints written as they are in the mathematical notation. This is up to you. Again, we're not telling you how to use sample or how should you use it, but MP enables users from many different backgrounds to model these complex constraints without having to worry about the details of linearization, getting the big M value right, reducing the number of your auxiliary variables that you introduce into your model, and so on. So we'll talk about MP at a later point, at some point, but just for you to be aware of what it actually is. Which is another another part of the modernization of AMPL. What actually are we shipping in the toolkit? What ends up reaching you? These are the tools that we're going to put not only in your students' hands, but also in your hands. Going back to the Visual Studio Code plus the AMPL extension, this extension will allow you to have syntax highlighting, so you can know what you're writing on your model, your dot files. You can debug and you can run your models and your problems through AMPL. You have an integrated terminal of the AMPL process, the AMPL shell, and you also have access to the Git version control. So this editor is most likely already being used by your students, specifically in the context of uh, data engineering or data science or similar software workflows. Visual Studio Code is, and again, we're not getting paid by Microsoft to advertise this, but it's just the reality that Visual Studio Code is the most used editor out there. It's free, it's open source, it's quite easy to use and to set up, and you can customize it however you want. So we're moving towards that direction as well. There are forks of Visual Studio Code that have different licensing types. If you are not very comfortable with using a Microsoft product, then you can use a forked open source product based on Visual Studio Code, and the AMPL extension will work there as well. The Jupyter Notebook part, if you want to ship a form factor that has the assignment, the narrative, the theory, the text behind the code, and then lastly the code and the output and what should it actually look like. You can ship it in a single artifact, a single file, and your students are able to run this without installing anything. They can run this on the cloud, on the Google Colab platform, and this should fix the doesn't work or doesn't run on a machine problem. And lastly, the MO book and the AMPL bot. Again, the MO book is a new textbook. It's not a replacement of the AMPL book with the Black Panther. It's a new book completely by different authors. And the AMPL bot is an AI assistant that is specifically more accustomed to AMPL syntax and newer stuff. So we'll talk about this later. So for example, what the MO book actually looks like, what's an example of this? Scanning the QR code should lead you to this same link. obviously we'll be sharing the material of the webinars with you at the end, so you can go over this on your free time. So I'll click on this link and it will bring up the notebook, but I see that you cannot share my screen, so I'll change very briefly. Okay. Please let me know if you can see now my browser. I think you can. So this is the
Yes.
MO book. The MO book is a book that is a web page, so you can access it. And as I said at the beginning, you have linear optimization, mixed integer, network, convex, nonlinear, stochastic stuff going on around. So we'll go over this very basic example, just a linear problem. So this is the text representation of the book. As you can see, it has all of the text and the Python code and the mathematical formulations. But the advantage of the MO book and the whole advantage of Colab is that I'm able to work and to go my way through the Colab notebook. I don't know, Juan, if you want to take it from here.
Yeah, sure.
Okay.
All right, so let me just share basically the same thing that Eduardo was showing there. All right, so this is where the link should take you, basically, to the MO book page. Just before we dive into the collab thing, this book was written for Aaron. Was written by these professors. These professors. So yeah, so basically, this was an academy effort there to put up with all this kind of material. So yeah, it's a great resource for basically most of today's challenges in optimization there, just to give them the credit. So, all right, so once you're here and you click in this rocket thing, the rocket symbol, you can fire up the collab. We'll be basically using these kind of tools on Thursday or your VS Code locally if you want to. But basically, here in Collab, we are running in a server, which we can start here by connecting. So we can see the notebook, and the notebook will have text and code declarations, and we can run everything basically directly here. So that's the cool thing about this. You can have a narrative, you can have the explanations there, and this is what this model does. I don't want to go deeper into this, so not to waste a lot of time into this specific thing. I'll be using this to explain a little bit more of Collab if you didn't know it. So these are basically the different sections that are in this notebook and different kind of data if you want to upload some data or if your code creates some data, it will show up here in this little folder thing. So basically, so we are the author, so we can run the code here anyway. So with these kind of commands, you can install the libraries into this kind of server. Here we are installing AMPL. Pandas, I think Pandas is not necessary. I think Colab is already has already the Pandas library installed. So yeah, basically here it is explaining something about the data and about the example that is based on. I just want to show you a little bit, a couple things. First thing, this is if you're on Windows, you're probably watching here the correct grammar. That's something that happens with Mac. So basically, sorry, I forgot what you have to click here. I think is Alt click or Command, something like that. Sorry, I'll have it for Thursday. I forgot the thing you click here to avoid this from happening. But if you're on Mac OS, you're probably watching the little square like me. But okay, the important thing I wanted to show is here's how you activate AmplePy and your Ample environment in the collab. We're gonna do that on Thursday. And this one, I think Eduardo mentioned it a couple slides ago, a couple minutes ago. So what we're doing here is with this magic command, we are running Ample, basically Ample script or Ample language. So we are on the fly defining the sets in this case. Let me just be running here just for you to see. So yeah, so we'll be running basically the AMPL code. Here I'm using a community edition by default. The point here on Thursday will be to use your own academic license that includes the commercial solvers. But I think it's worth mentioning, you can use a community edition in Collab. So I haven't installed anything. I'm just using my browser. I'm already able to use AMPL and to solve optimization models with open source solvers, basically with internet connection is all we need. All right, so yeah, here we are defining the model and explaining through the definition of the model what's going on. So that's a very cool thing you can do with this kind of tools in Colab, especially useful for teaching. So all of this is basically what would go into that mod file. So yeah, the sets, the parameters, but here we are kind of going deeper into the explanation of what we're doing here. Yeah, uh, this is basically creating the data. Sorry, I think I missed something somewhere. Yeah, I think I didn't run the part that created the data. Sorry. If you run everything, it should work basically. Okay. And then it will basically set the data. So this is the part that that file would be replaced by. So it would be this one. And then you're solving using heists, which is something we already mentioned. So yeah, so this is basically one case where we are using Google Colab to showcase everything that can be done with Python. We'll try to run this again on Thursday, but with another model, and we'll basically go from that run file or a script in AMPL file, and we'll see where each part of that file actually fits the new Python scripts. Yeah, so that's more or less it. Like I said, I didn't want to go deeper into this model to not to respect the hour we have. But I'll mention just a reminder, and rest assured that everything you do with AMPL today, or with the legacy IDE, or with some other AMPL legacy tool, it will work with using the modern Python-based workflow or other language API-based workflow. And the reason is, well, this may be new for you, or new tools that you haven't used yet, but it's been around a couple of years. Actually, Amplify was released in 2018, 2017, one of those years. So yeah, Ample has been trying to basically migrate everything that you could do before to this new kind of workflow. So yeah, rest assured that you will be able to do it. All right, yeah, I guess I'll give you back the screen.
Yep. Thank you, Juan. So yeah, as you saw, obviously we didn't go into further detail of the model. The point of Thursday session is to run through a model, through Python code and so on. But you should have been able to see that the same AMPL syntax is being used, the variables, the objective function, the constraints like that hasn't changed. The model is still solver agnostic. We use hikes, but you can use Cplex, Gurobi, whatever soldiers you like. And that all of this is running on the cloud, on the browser. We didn't install anything. Obviously, you're free to install. It's just another version, another way of doing things. That's our whole point. We are not trying to make you change or force you to change, but we'd like to show you better tools for you to make your own decision and say, okay, maybe I should look into taking, if not all of the components, some of the components that were shown. So what this actually means for your team and for the whole academia ecosystem. We're introducing a revamped version of our licensing. We have now 3 versions of academia-specific licenses. You can read more information if you visit ample.com/academia. But these are basically the 3 licenses that we want to cover very briefly. The A4A, the Ample for Academics license, is available to anyone with an academic email. So not only you, but for example, also your students. Say you have a PhD student doing some research using Ample and solvers, then they are free to join us and sign up for this license. This license will include 10 commercial solvers plus all of the open source. We are missing 3 commercial solvers to get on our completely free academic license. But for those 3 solvers, we offer a heavily discounted license for the academic users. This license doesn't have any time limit. You just have to renew it every 12 months through our portal. And this is a self-serve form. Like you sign up and you fill up some data, and the license should work like right out of the box. There's no human involved in the process. It's free, obviously, and it's for individual use. So you can use it on any an unlimited number of machines, but they must be tied to your name. The A4C license is most likely the license that you are already familiar with, the AMPL for Courses license. This is a license that the instructor or an assistant of the instructor must request. This is a distributable license, meaning that this is the license that you are able to share with your students for a course. This license will include all of the commercial solvers and no fees associated. This license can last from 4 to 6 to 8 months. It's just a shareable activation link that will cover the whole class. And I'll show you briefly how it looks like, the form. So again, I will click on this link and I'll share my screen again, my browser. So can you see my browser? Okay, I am assuming you can see this. So this is what
Yes.
the import for courses form looks like. Let's say I am the primary instructor. I am the guy requesting the license. So I'll click on yes. I'll input my course name, number, and title. Let's say, I don't know, Introduction to Linear Optimization, 101. The course duration, as I told you, it can range from 4 to 8 months. I'll just say that this will expire in 6 months, a normal duration of a semester. These are questions for us to know better what our users are doing. I'll say that yes, we'll be using AMPL with Python, and we'll be using the MP stuff, the automatic reformulations I briefly covered. This is my information, the LinkedIn profile to validate your identity. The job title, for example, I'll say professor. Let's say I'm teaching at a university of cool place, and my department is the mechanical engineering department. And once you submit the course, okay, great news. This always happens, but this should work. If you try it on your end, this should work. We look into why I popped this error. I think it's erroring because since I already have a registered Ample account and actually an Ample admin account, I think it's not working, but this should work for you. This is the form when you are not the primary instructor of the course. You just have to fill out the information of that primary instructor if you're not the main person. And going back to the presentation, we
Yeah,
also have,
it may also have to do that you try that with your Ample email and not an academy email. I'm assuming. I'm not sure.
yeah, we'll have to look at it. And lastly, this one is a new offering, and I think this one is quite interesting. This is the ACS, or the Ample Career Starter License. This license is aimed towards recent graduates from any course, from undergrad classes, master's, PhD classes. Recent means that they have graduated in the last 24 months, and this will allow your recent grads to start their optimization career, as the name implies, because this will give them access to Ample and to all of the commercial solvers for free over a period of 12 months with commercial usage permitted. So meaning that if your students want to, they want to start their own company, they want to build their own stuff, they can use this license and they have a year to build whatever it is they want to build. And at the end of the year, they are free to transition to a paid license. This actually is also requested through a form. So I'll click on this again and I'll show you very briefly what the form looks like. I think we have a question. Okay, never mind. So I'll share my screen again and I'll show you what the form looks like for the career starter. I think you can see this now. But yeah, the Academia Career Starter license is what we're offering for recent graduates. As you know, bridging the world between academia and industry it's a hard thing to reach. So the purpose of this license is to help users and to help recent graduates to transition and to make use of the same skills that they learned in their studies towards a real world application. So, for example, I'll say that I studied that again the same. I don't know. I play my real university, industrial engineering, let's say, and I'll say that I graduated in 2024, and I graduated at some point in December. I got a degree, bachelor's, and I'll say I'll build a commercial platform, access to solvers. And again, same information as before, and I'll certify that I acknowledge I graduated from a recent program within the last 24 months. And this will enable your recent graduates to have a fully fledged AMPL license with all of the commercial solvers for up to 12 months. So that's an interesting offer, at least to me, because for example, if I was in that position that I was an early graduate and I wanted to do stuff with optimization, but I had to get a license. But as you know, academic licenses are restricted to academic usage only. So this license is not attached to academic use. You can do commercial stuff, whatever you want to do with this. You have 12 months to build your own uh, product or whatever it is you're trying to build. Going back to the presentation, I think we have one more question. For intro course in optimization, what are advantages or disadvantages of the A4A and A4C licenses? Thanks. The A4A license is geared towards your individual usage of AMPL. Let's say you are working on a paper using AMPL and XYZ solvers. The A4A should be the one that fits your use case in there. You want to prototype problems, you want to build your coursework and before the course itself, then you can use your A4A license. And this is tied to your name only. And you can run it, for example, if you have a computer in your university network, you have your cluster there. You can use your A4A license to activate within that cluster. And let's say that you have in your house your own PC or your own Mac OS or laptop or whatever. You can use the same license to activate in that machine. And that's named to you, and you can use it, and you can do whatever you want with it in an academic context. The A4C license is geared towards a specific course, a specific course in a specific semester. And the A4C license, the strength that it has, the advantage is that you can share it with your students and whatever solvers you want to use. Let's say that you have a nonlinear course and you want to select only nonlinear solvers, then the license will include those nonlinear solvers. So when your students download AMPL through the A4C license, those solvers are already included. The disadvantage of the course license is that it has a set expiration date because it's tied to a course, and you should only use it for course work. So yeah, those are the main advantages and disadvantages. How are we doing on time? Okay, we're past the hour, so I'll
We are, yeah.
wrap it up briefly. Where to start? We have already showed you. If you want to sign up for an Apple for Academics license, you can do it through our portal, portal.ample.com. The A4C course request is this form that you have to fill. And the ACA scores form is also the same link that you have to fill. So ideally for next session, you should have already a license available either through A4A or A4C. So yeah. And lastly, just to wrap up things, part two is happening on Thursday. What are we going to do on part two? We are going to have a hands-on approach. We're going to run through code. We're going to solve your answers, your technical questions of how do I transition from the older workflow to the new one, and having a better approach of things. What we expect for you, it will be nice for you to have already a laptop with Python 3.10 installed, preferably. If not, it's not a hard stop. Visual Studio Code installed. It's recommended again. We will show you how to install the extension. A .mod file from your course, a model that you want to run, an example, and preferably your academic license already activated. What we will do in this session is that we will install AMPL and AMPL Pi, the VS Code extension. We'll run a baseline model that we already have prepared as an example, and we'll show how to switch solvers and access the whole AMPL platform with your A4A license. If you have further questions, you can reach out to Juan or me via our emails or towards our general academic inbox at academia@ample.com.
Yeah.
That's it for today.
Yeah, just that link over there with the GitHub repo, that's somewhere you can find this presentation and the material that we'll be covering on the next session. We'll probably be sharing anyway after the webinar these same things. And also, I think that the last question that Ina answered, I think in the Q&A was quite important because someone asked the size of the problems, that the limitation, the answer is there's no limitation in the size of problems, so you basically can use it for any problem you have with basically all the most important solvers in the A4A or all the commercial solvers in the A4C. Yeah, we'll probably dig a little deeper into that on the next session. But also, if you're used to an Ample for Courses bundle where you download, that may have changed a little bit. But yeah, well, we can go deeper into that in the second part.
Thank you, Juan. I see one more question. I'm not sure I fully understand. I use a default license for my course. Would it still work?
If you're referring
Um,
to a community
yeah,
edition, like the default where you use Colab, and it is working for your course, then it will. But if you want to probably use Ciplet, Groovy, or some commercial solvers, well, the community edition does not include that. So we'll recommend if you're in academy, well, use all of these solvers and explore them. But if it is already working with the default, then it will still work. Yeah.
yep.
Okay, I see no more questions, but if there are any other questions following today's session, again, please feel free to either reach out to Juan or Eduardo or academia@ample.com. We all monitor that email, so we'll get back to you with the right answer. Thank you so much, Eduardo and Juan, for joining us, and for everybody for staying on past the hour here.